Imagine the most powerful hurricane in Earth's history, with destructive winds crushing every city in its path. Both are terrifying atmospheric vortices, yet their internal mechanics are fundamentally opposite. But when stepping out into space, our most terrifying storm is nothing more than a tiny speck of dust. This is the Great Red Spot on Jupiter, an atmospheric monster that has been raging continuously for hundreds of years. A storm large enough to swallow planet Earth whole, with plenty of room to spare. What exactly sets an Earth tropical hurricane apart from Jupiter's planetary superstorm? How vast is the gap between their destructive force, energy sources, and overall lifespan? Let's put these two planetary monsters head-to-head on our scientific balance scale right now. Welcome to the channel. To kick things off, let's dive straight into our very first category: scale and size.
On Earth, a Category 5 super hurricane averages a diameter between 500 and 1,000 kilometers.
The largest storm ever recorded on Earth, Typhoon Tip in 1979, stretched across roughly 2,000. That size was immense enough to blanket nearly all of Southeast Asia, or half of the North American continent. Yet when compared to Jupiter's Great Red Spot, those numbers appear remarkably modest. Today, the Great Red Spot measures approximately 16,000 kilometers across. This means you could drop our entire planet Earth inside this single storm, with room to spare. Historical telescope sketches from the 19th century showing a red spot 3x larger than today. Even more, back then, it was wide enough to fit 3 Earths lined up side by side in its core. Beyond width, the Great Red Spot roots itself deeply, plunging 300 kilometers straight down into Jupiter's atmosphere. By contrast, Earth's hurricanes are confined to our troposphere, spanning a thickness of just 10 to 15 kilometers. In terms of total air volume and involved mass, Jupiter's storm dominates by thousands of times over. But what fuels these colossal giants? Let's move on to Category 2, fuel and energy sources. Earth's hurricanes are heat engines fueled by warm ocean waters, reaching at least 26.5 degrees Celsius. Evaporating water vapor releases latent heat upon condensing, driving low pressure at the core and pulling in air. The Coriolis effect from Earth's rotation spins the air streams into the familiar vortex structure we recognize. As soon as a hurricane moves over land or cooler waters, its moist fuel supply is cut off, causing it to decay. Jupiter, however, is a gas giant planet. It possesses no solid surface or warm oceans whatsoever. The energy driving the Great Red Spot stems from Jupiter's internal thermal energy, radiating out from its core. This internal heat merges with powerful atmospheric jet streams, blowing in opposite directions, flanking the storm. Trapped between opposing jet streams, the Great Red Spot rolls continuously like an endless mechanical ball bearing. Crucially, Earth's hurricanes are cyclonic, low pressure, whereas the red spot is an anticyclonic, high pressure storm. That means atmospheric gas in the red spot is pushed outward from the center rather than sucked inward. So how do their wind speeds compare? Let's check out our next category right now.
Super Typhoon Haiyan in 2013 set record-breaking sustained winds reaching up to 315 kilometers per hour.
Winds of that velocity are roughly equivalent to the takeoff speed of a commercial passenger airliner.
Yet along the outer edges of the Great Red Spot, Wind speeds range between 430 and 680 kilometers per hour. Intriguingly, at the absolute center of the Great Red Spot, conditions remain strangely calm, with almost no wind. But the most breathtaking contrast between these two phenomena lies in their lifespan.
An Earth hurricane lasts anywhere from a few days to a maximum of 3 or 4 weeks before fading away.
Meanwhile, humanity has continuously observed Jupiter's Great Red Spot ever since the year 1830. Many astronomers believe it is the very same storm spotted by Giovanni Cassini in 1665. It survives so long because Jupiter lacks a solid land surface to generate friction and slow the storm down.
It also routinely consumes smaller surrounding vortices, effectively recharging its own power supply.
Recent data, however, reveals the red spot is shrinking and could potentially disappear in a few decades. Let's step into a hypothetical scenario. What if the Great Red Spot appeared on Earth today? First off, at 16,000 kilometers wide, this single storm would completely swallow Earth from pole to pole. Earth's sky would be plunged into a murky reddish-orange gloom, permanently blocking out all sunlight. Winds blasting at 680 kilometers per hour would flatten every city, skyscraper, and piece of infrastructure in seconds. The extreme high pressure of the red spot would crush Earth's atmosphere, fundamentally destroying ecosystems.
Filled with toxic ammonia and methane gas from Jupiter, Earth's air would instantly become unbreathable.
Surface life across the entire planet would face total extinction within just a matter of hours. Fortunately, under the laws of physics, if the red spot landed on Earth, it would quickly destroy itself too.
Earth's rocky surface and massive mountain ranges would generate immense friction, shredding the storm apart.
Lacking Jupiter's internal heat engine and jet streams, the Great Red Spot would dissipate in a few days. This scenario serves as a stark reminder of how fortunate we are to enjoy Earth's mild, life-sustaining atmosphere.
In summary, Earth storms are small yet dynamic, regulating our planet's vital heat balance.
Meanwhile, Jupiter's Great Red Spot stands as a monument to the raw power and hostility of deep space.
Don't forget to like, subscribe, and hit the notification bell so you never miss our next cosmic journey.
Thanks for watching, and we'll see you in the next scientific deep dive.